Assalamualaikum and good day to all. So in this slide, I will try to continue again what we already done for the last lecture, Introduction to Programming Structure. In the previous lesson, we already talked about regarding modules and also functions and what is cohesion and couplings. So try to read again on the previous slides or watch my video regarding these topics. Did you remember what is formal and actual parameter? So actual parameter will be placed in this area, meaning that in the call function or the call module, while the formal parameter listing in the calling functions. There are two terms in the modules that we call as a calling modules and also called modules. So what is called modules? Call module is a contains the definition of the function, for example, what and how to do, while the calling module contains the input, which is the actual parameter, which is given to the call function, which then works on them because it contains the definition, or other words is a function definition, performs the procedure specified and returns if anything is to be returned. In this example, I want to show you regarding calling module and also call module of this program. So control sum is a calling module, while the read, calculate and also print are the call module. So the call module here we call as a module definitions. Another terms that is important in these topics is a call by reference and also call by value. So from this diagram, the original value, is it modified or not modified, is reflect to the is it called by value or called by reference. So if the original value is modified, so we need to use the call by reference instead of by using call by value. Later we're gonna see how we can use call by value or call by reference in the module. So pass by reference and pass by value. In pass by reference, we are passing the address of the original argument instead of we are passing the actual value to the modules. So, however, in the pass by value, we are copying the original arguments is manipulated, which doesn't affect the original arguments. So compared to the reference, we are passing the address of the value instead of the original value. As we can see in this slide, is the original value is not modified. So we're gonna use the call by value. So value being passed to the function is locally stored in the function's parameter in the stack memory locations. So if you change the value of the function parameter, it is changed for the current functions only. This one, it will not change the value of variable inside the caller methods such as in the main functions. So we have one module here which is a change module, and another module we call as a main, which is the main function that we have here, right? So whenever we run the program, the C program will try to look on the main functions first. So we have a variable here with the value 100 for variable x. Okay, so we print out before function call x is equal to still 100. Okay, so change x here, we are passing value in functions. So the value of x here is equal to 100. So meaning that we are passing a value 100 to these functions, and being copied to the another variable which is num. So right now we have two different variables which is x and also num that have different memory locations. So num here will store 100. So right now we have two different variables that have two values, 100 in num and 100 in x. So before adding values inside function, is this one is 100 because we are getting the value from here. So right now we are having a calculation in this statement. 100 plus num, which is 100 as well, equal to 200. So after adding value inside function, we get the output 200, right? So whenever we go to this line, okay, so it doesn't have anything, so the program will return back to where it's being called, meaning that it's already done this line. So the next line that we need to cover is this one. So after function call x, this one we still got 100 because of what? Because the function is locally stored by the the value being passed to the function is locally stored. So meaning that the variable of x is only applicable in these functions only. Now we look on the example of call by reference, meaning that we modify the original value because we pass the reference, meaning that the address of the variable. Instead of we are passing or copying a value to a functions, we can use the address of the value or the address of the variable to the calling functions. Try to look on this example. We have two different modules, and we have main module and also the change module. So right now we are starting from the integer main module because whenever we run the program, we will try to look on the main module first. So now we have integer x equal to 100. So x will have a memory location of it and 100 of value. So before function call x, right now we have 100. Okay, so the program will look on the next line, this line. So passing reference in function. So in here we're gonna use the ampersand symbol. This one we call as ampersand symbol, and x that referring to we are using this one as the address of variable x. We don't pass the value of 100, but we are passing the address of memory location of variable x to these modules. So right now here we will have the address of x instead of the value of x 100. So in the change module, we're gonna use the star symbols that represent we are getting the address of x to this variable. So integer star num, right? So num will hold the address of x, which is being passed from this line. So before adding value inside function num, so we have the address of num that reflects to from this one, which is 100. Okay, done for this line. It will read for the next line. So 100 here is we have some increment, accumulating. So we have here star num, which is we're gonna use this statement in order to access the value of num, which is from this statement. So right now star num here it was 100. So after adding value inside function num, this one will be 200, right? So it looks like this one. So star num equal to star num plus 100, which is this one is 100 plus 100, and 200 will be stored into this address, right? So we call this one as the address. So that's why after the passing preference function, which is this line, it will read this one. So after function call, the value of x right now being updated into 200 instead of 100, because we are accessing the value of x, which currently x, and we do some calculation to update the value of address x from here. This algorithm consists of several items, which is the formal and also actual parameter, the calling modules and the call module, and call by value and call by reference. As you can see from this algorithm, we're gonna have the actual parameter here, while this one is the formal parameter. In this actual parameter, we have what we call the call by value and also call by reference. Call by reference, we're going to use the star, and also call by value is the name of the variable itself. And we have another term we call it calling modules and also the call module. This three one we call it a call module, means that all the definitions, all the processes being done inside this call modules. So while the calling modules is this, instead of calling module written by value, written by reference, we have another term that we call as a return value. So what is return value? So the value is written out of the call module into the calling module, the result of the function. For example, you want to return a value, or you want to return the address of the value back to the calling functions. There are two ways to send data from one module to another module. The first one here we are call by value parameter, or we are going to use call by reference as I mentioned in the previous slide. How we can send data between modules? First one, we're gonna have a call by value parameter, which is we're gonna send the value of the variable. So this value of the variable is sent to the call module by the calling module. So the call module will then make a new memory location for this variable, since it not have no knowledge of where the variable is stored by the calling modules. So when the call modules make changes in this variable, the changes will not affect the variable in the calling module because the parameter has a different memory location. So meaning that we're gonna copy this variable into the other modules, and this variable can be usable is only the particular modules only. While we have another term, we call it a call by reference parameter, and this time we're gonna send the address of the variable instead of we are sending the actual parameter, which is the value, to the modules. So in this call by reference, we're going to use the x3 symbol in front of the variable name in both actual and the formal parameter listing. So right now, we're going to utilize the memory locations of the variable and not the value of the variable. So when the call module changes the value of the parameter, so the calling modules will see the change because they are using the same memory location. Imagine that we're going to update the value of the current variable by using the same memory location. Try to look on this algorithm. So call by reference meaning that we are sending the address to the other modules. So call by reference, we are using the asterisk symbol instead of the name of the variable. The asterisk symbol in the call module changes the value of the parameter. The calling module we see the changes. So right now we're going to have three modules. We're going to see on the first one, the read module, this one. You have two parameters, num1 and so num2, which is this one is the address of the variable. Also, this one is the address of the variable num2. Right now, num1 star num1 contains the address of variable num1. Star num2 contains the address of variable num2. We're gonna pass this address to this parameter, the other variable as well. So while the call by value, which is we are sending the value without using the asterisk symbol, and this one is not affecting the value in the calling modules. Imagine that we have this module, read module, and we have two parameters that we're gonna pass to the modules. So we have two address of num1 and also num2, and this variable contains the address of 2000. Imagine that 2000 is a memory location that in the machines, and this one we're gonna have some kind of the value. So address of 200 is receive value of n1, which is found in 2000. 2000 will be stored in this address, while 2002 for the address num2 will be stored in this parameter. So we're going to use the enter n1 and n2. We print n1 and n2. Since we are entering for two numbers, which is the address belongs to num1 and so num2. So anything that being changed in this one will be changed in here as well. We look on the second module, which is the calculation modules. So in this module, we have three parameters, which is num1, num2, and also sum. So try to highlight here, there are two different call by address and also call by value. So num1 and so num2 are the call by value, while the star sum here we call as a call by reference or call by address. So since num1, num2 here are the variables, so we will have the address of this one is 2000, similar in the read module in the previous slide. And also num2, similar in the previous slide as well. But we have another parameter which is the star sum, and the address is 2004 will be sent to the module calculate. So right now we have 35, this one is 12, and then we do some calculations here for 35 and also 12 again. We have the other address as well because we're gonna have a copy of value to the new variable. So num1 will have new variable 4000, num2 will have a new variable which is 4002. So inside this module we do some calculation num1 and so num2, which is this will be the product of summation equal to 47. This is the last module for this example, which is we're going to display the value that we do in the calculate module just now. So we have a variable of sum, and we have a sum here, which is we have a value of 47, and 47 will be sent to the print module. So in this print module, we will receive a copy of 47 to here, instead of we are sending the address of this one, because we are using call by value. So right now we have some variable without any asterisk symbol, which is 47 will be stored into this variable, and then the end of this one will print out the output of sum. Okay, we move on a subtopic for this topic, introduction to programming structure, which is coupling diagram and data dictionary. So in coupling diagrams, shows the variable are passed from one module to another. So meaning that we try to visualize the interactions between the module itself by using the coupling diagram. So coupling diagram relates with interactivity charts that we already covered in the previous topics, and the way of sending data, which is send value, or we are sending the address from one module to another. And coupling diagram can be drawn based on the algorithm. So we try to look on this example coupling diagram based on an algorithm. So we have an algorithm. So try to draw coupling diagram based on the algorithm. And what is the first steps? So the first step is draw the interactivity chart, and how to analyze many modules you need to draw. So right now is we're going to analyze a modules based on the algorithm that we have. We have a control ringgit converter, we have a read module, we have calculate total module money, calculate total text, and also print. So in coupling diagram, we're going to have the interactivity between this module. So the next step here is to link between two modules. You need a line. There are two types of line, either single-headed or double-headed. For single-headed, we indicate this parameter are called by value, while for double-headed indicates a parameter are called by reference. We already touched on call by value and also call by reference in the previous slide. For example, in this diagram, we have a control ringgit converter module and also read module. So how the interactivity between these two modules? Let's say we have an algorithm of process read in the control ringgit converter, which is this is the calling module, and we have a process read, and we are sending three parameter: money, rate, and auto text. So right now, these three parameter we have called by reference, which is we're gonna use a double-headed lines. For try to look here, so money and my are the variable that we have here. This one reflects to the first parameter, rate and rate the second parameter, and text and also text for the third parameter. So you can see here is double-headed lines that reflects to the type of the passing parameter. What about interactivity between control ringgit converter and also calculate total money? So how does the coupling diagram looks like? So the diagram is look like this. there are two difference calling by reference and also calling by parameter value parameter in this interactivity. So try to look on this one, money to the my, rate to the rate, and star total money to the star total money. So we have two parameter which is called by value and only one parameter called by reference. So what about control ringgit converter modules and also calculate total tax? So how the interactivity looks like? So we try to look on this one, tax and also tax is called by value, total money to the total money called by value, and also star total tax and star total tax are called by reference. So the diagram should be like this one. Remember again that we have double side for the call by reference and also one headed for the call by parameter. And how does the interactivity between control ringgit converter module and the print module? As you can see here, we have two parameters which are total money and also total tax are called by value. So the diagram for coupling diagram for this case is using. Previously we look on the interactivity between two modules. So how we can combine all modules and have the interactivity between the main modules and also the sub modules. So we have one main module called as a control ringgit converter and other sub modules that are read, calculate total money and calculate total tax and print. The interactivity of coupling diagram we presented into this one, into one diagram. We move on the next subtopic, which is data dictionary. Data dictionary help to keep track of the variable usage in the program. So this one contains a list of all items, variable names and data types and the module that the variable are used. We are using this diagram, coupling diagram, in order to present all the variables, interactivity, modules, and then we convert it into the data dictionary. These are the tables that represent the data dictionary, which is come from the coupling diagram just now. So we have a data item, variable name, data type, and also modules. This is another example of coupling diagram in data dictionary. So we have the example of algorithm of control pay, and we have three submodules which are read, calculate, and print. So in this module, we have different kind of parameter which are called by reference and also called by value. So how we can present the algorithm into the coupling diagram? So the coupling diagram for the previous case study looks like this. So remember again, we have single head and also double-headed arrow that represent the call by value and also call by reference. This table again, we represent the coupling diagram algorithm into the data dictionary. Remember that we have four columns that represent for data item, variable name, data type, and also the module that interact to this data item. Now we move on this example, which is the interest control. In this flowchart, we have one main program, which is the interest control, and we have three sub modules. They call as a read module, calculate module, and also print module. So each of these modules have its own specific task. For example, for the read module, it will read the principal, interest, years, and also the time, and also do some very basic calculation for the interest. Why the calculation here is to calculate the total amount of interest, and the print module is to print out the amount, principal, time, interest, and year. Now we are at the end of the slide here. So previously we learned on how we do the coupling and also cohesions and also the modules. So we can try to evaluate the proposed algorithms, modules, cohesion and couplings by using a set of data, or we can use go through the algorithm instructions one by one, and also we can use a test checking table, which is we already covered in the previous topic. So enjoy your watching the video, and don't forget we have a new topics in the next week, which is introduction to programming. Stay tuned.